We work on protective systems for civil and military applications, for example, the crash absorber in your car, but as well for bomb and blast protection systems and other protection systems in tanks and other armored vehicles. Further applications are, for example, mobile blast protection shields for the bomb disposal service here in Hamburg, which can be used to protect them during the disposal of grenades from World War II. Protection systems for military applications often work according to the disruptor-absorber principle, which means you have in the direction of your threat, of the strike, on the strike face a very brittle material, which acts as so-called disruptor, which leads to the disruption of your projectile, for example, in smaller parts, and that the kinetic energy of this is lower compared to your bullet before it's fragmented, and after that smaller parts have been absorbed the energy by absorber behind your disruptor. And for such an absorber, you can use, for example, such stochastic foams, which are metal foams and they can be compressed and act them as your crash absorber. Due to the collaboration with nickel SLM solutions, we were able for the first time to have such large specimen sizes, as well as we have a really good surface quality, which makes it much better for the mechanical properties of the structure. Here, for example, we see what happens if you use only a metallic plate. That was the same test where we have used a kind of pipe bomb, and it absorbs the splinters as well as the blast. But what we see on the back side is that there are a lot of more second projectiles which are produced, and they are further threat for your life. And if you have only such a big metal plate, it's not possible to absorb really the energy from your blast. The energy goes through the structure, and in worst case, it comes to your body. Let's see what happens if we use such an additive manufactured plate, which is on the same weight as our reference metallic plate. It consists of this structure, and it's made of steel as well. We see that the same pattern or similar pattern is absorbed from the splinters in our structure, but on the back side nothing goes through. We do not have this second order projectiles, and there's not such a big deformation as we have seen on the pure metallic plate. Additive manufacturing is definitely a future technology because it gives better freedom of design. It makes easier to change the dimensions of the structure and to give better properties due to the gradients, and hence we can specifically tailor the property of the whole structure.